Hello students, welcome to Code to Serve Academy. Today we will start our chapter Trigonometry. So what is trigonometry? So as the name suggests, trigonometry is made of word trigon and metron. This trigon and metron are derived from Greek words. These are Greek words. The meaning of trigon is the triangle or any figure having three sides. Okay, and the meaning of metron is to measure. So what is trigonometry? Trigonometry is actually the science of measuring triangles. Okay, it is actually the science of measuring triangles. It gives the relationship between the sides and angles of the triangle. Okay, so the use of trigonometry is very vast. In our celestial body parts, for example, Earth, planets, stars. Uh, our astronomers use trigonometry to find different distances which were very far away from Earth, such as the stars which were very far away from Earth. The distances from stars to our Earth was not known to us. Okay, so to find the distances between Earth and stars, this trigonometry was used. Okay, so now we will know about the term called trigonometrical ratios. What does it means? So for a triangle, we know that a triangle has three sides. A triangle has three sides. So for an acute angle triangle, what we see that in a right angle triangle, if theta is an acute angle, in a right angle triangle, if theta is an acute angle, we will get three sides. The first side will be this, the second side will be this, and the third side will be this. Any triangle is of three sides. But for right angle triangle, the side which is away from the theta, which is directly away from the theta, is termed as the perpendicular. So it is the perpendicular of this triangle. This side beside this theta is the base of this triangle. Okay, this is referred as the base of this triangle, and this is called the hypotenuse of this triangle, and this side is called hypotenuse of this triangle. So if these are three sides and we are said to find out the ratio between these sides. So for three sides, we know that any ratio is in the form of A is to B. A ratio is in the form of A is to B. So these three sides can be represented in this type of ratio by six ways. What it will be? It will be like, let us suppose that we are taking P and B. So it will be PA by B. If we are taking B and P, it will be like B and P. If we are taking P and H, it will be like P and H, P upon H. If we are taking H and P, it will be like H upon P. Okay. And similarly, when we take B upon H, it will be like B upon H. And when we take H and B, it will be like H upon B. So from these three sides, H, B and P, what we got? We can make six ratios. We can make six ratios. Okay. So for these six ratios, what was done? As name was given to these ratios. Different names were given to these ratios. So what were the names given to these ratios? The first name which was given to P upon H. The first name which was given to P upon H was sine of angle theta. What was it? For P upon H, it was sine of angle theta. So we can say that this sine theta is actually perpendicular upon hypotenuse. Perpendicular upon hypotenuse. Similarly, the second ratio, that is B upon H, was said to be cosine of angle theta. Was said to be cosine of angle theta, and it was like B by H. This B by H was referred as cosine of angle theta. Similarly, the third one, that is our P upon B, was referred as tangent of angle theta. This P upon B was referred as tangent of angle theta. In all these, the convention, we write it as sine theta, but the saying of this sine theta is sine of angle theta. Similarly, the saying of this cos theta is cosine of angle theta. We cannot say cos theta to B upon H. We will always say cosine of angle theta, that is cos theta is equal to B by H. This cos theta is actually cosine of angle theta. This is actually cosine of angle theta. Similarly, tan theta, that is tangent of angle theta, is equal to P by B. We cannot say tan theta. We can say tangent of angle theta, that is tan theta, is equal to P by B. Now, we see here that beside this P by B, along with this P by B, along with this P by H, along with this B by H, we are getting reciprocal of these ratios. We are getting reciprocals of these ratios also. So these reciprocal of ratios were termed as opposite trigonometrical ratios. It were termed as opposite trigonometrical ratios. What were they? So our fourth one was cosecant of angle theta, that is opposite of sine theta. Cosecant of angle theta is actually opposite of sine theta. So we can say that it is equal to sine theta was what? P upon H. So it will be H upon P. That means hypotenuse upon perpendicular. Similarly, the fifth one was given the name secant of angle theta. What was it? It is the reciprocal of angle cos theta. But it is the reciprocal of cosine of angle theta. So this secant of angle theta is actually what? H upon B. This H upon B is secant of angle theta. Similarly, for B upon P, for B upon P, that is opposite of, that is reciprocal of tangent of theta, but it is given the name cotangent of angle theta. So मैं क्या कहना चाह रहा हूं, मेरे पास इन तीन साइड से 6 रेशियो पॉसिबल थे. इन 6 में से 3, जैसे कि एच बी पी अपॉन एच, बी अपॉन एच और पी अपॉन बी, साइन ऑफ एंगल थीटा, कॉस ऑफ एंगल थीटा और टैन ऑफ एंगल थीटा का नाम दिया गया इन तीनों को. और जो ओपोजिट थे इनके, जैसे बी अपॉन पी, इनको टेंजेंट ऑफ एंगल थीटा, कोटेंजेंट ऑफ एंगल थीटा बोला गया, ऑपोजिट है ये इस कारण से. सिमिलरली साइन ऑफ एंगल थीटा के ऑपोजिट को हम लोग क्या बोले? कोसेक ऑफ एंगल थीटा. सिमिलरली कॉस ऑफ एंगल थीटा के ऑपोजिट को हम लोग क्या बोले? हमने इन्हें कहा सेकेंट ऑफ एंगल थीटा. तो ये सारे नाम दिए गए इन रेशियोज को. ओके, दीज नेम्स वेर गिवन टू दिस रेशियोज. Now, so we got to know about these ratios and their values. To make it understand through mnemonics, we use a mnemonic called Pandit Badri Prasad. Pandit Badri Prasad Hari Hari Bol. Hari Hari Bol. By using this mnemonics, we can name any of these trigonometrical ratios. For example, if we are taking P upon H, this P upon H is actually sine of angle theta. So it is represented as sine theta. So this sine of angle theta is actually P by H. This B by H is cosine of angle theta. This P by B is tangent of angle theta. Similarly, the opposite of this sine of angle theta is cosecant of angle theta, that is h upon p. Similarly, this h upon b is secant of angle theta, and this b upon p is cotangent of angle theta. Okay, so we can use these mnemonics to learn the values of these trigonometrical ratios. Pandit Badri Prasad, Hari Hari Bol. Okay, now we will move to our next part. What is our next part? Whatever the trigonometrical ratios we have, whether it is sine of angle theta, whether it is cosine of angle theta, whether it is tangent of angle theta, whether it is cotangent of angle theta, whether it is cosecant of angle theta or secant of angle theta. In all the situations, the trigonometrical ratios will always be same for same angles. For example, if we take for sine of angle theta, let us suppose that we are taking two triangles. First of all, we have to know that this theta is an acute angle. Okay, so to find this trigonometrical ratios values, we are using this theta as an acute angle. If we are taking theta as an obtuse angle, we cannot say that it can be equal to P upon H. Okay, so what I am trying to say, this theta is acute, and the sine theta for this triangle A, C and B, or A, B and C will be equal to sine theta for triangle A, P and Q. Okay, so what I am trying to say, for this triangle, whatever the value of sine of angle theta is, it will be equal to the value of sine of angle theta for triangle APQ. Okay, so let us prove. So we are given two triangles. So what we are going to do, what is sine of triangle ABC? First of all, let us think what is sine of triangle ABC. Sine of triangle ABC is what? So for this is our P and this is our H. So we can say that sine of angle theta for triangle ABC is actually BC upon AB. It is actually BC upon AB. Okay, are you getting it? Sine of angle theta is actually P upon H. So this P upon H can be said as BC upon AB. So sine of triangle ABC, sine of angle theta of triangle ABC is actually BC upon AB. Similarly, sine of angle theta of triangle APQ, APQ is what? It is equal to, for this, it will be the P. Let us suppose that this is a bigger P. Let us suppose that this is bigger H, and let us suppose that this is bigger C base. So this will be bigger P upon bigger H. This will be bigger P upon bigger H. That means perpendicular upon hypotenuse for triangle APQ. So what we are getting? We are getting P as PQ and H as AP. So it will be PQ upon AP. Are you getting it? It is PQ upon AP. If we prove that this is equal to this, then we can say that sine of triangle ABC is equal to sine of triangle APQ. Okay. So what we are going to do? We will try to make these two triangles similar triangles. Okay, we know that two similar triangles have same angles. Okay, but they are, one triangle is of bigger size and one triangle is of smaller size. Okay, so let us see that these triangles, these two triangles are similar or not. So in triangle ABC and triangle APQ, what we are saying, this theta is equal. So we can say that angle BAC is equal to angle PAQ. Our first part, both are angle theta. So these two angles are equal, these two are acute angle and same acute angle. Now what we can say, this is 90 degree and this is also 90 degree. So angle ACB is equal to angle AQP is equal to 90 degree. Both are 90 degree. Similarly, what we can say, these two lines are parallel to each other. So their corresponding angles will always be equal. So angle ABC will be equal to angle APQ. So angle ABC will always be equal to angle APQ. What will be the reason? Corresponding angles are always equal. Corresponding angles are equal. So from angle similarity, we have proved that these two triangles are similar. These two triangles are similar. Okay. So these two triangles are similar to each other through this angle similarity. Whenever two triangles are similar, then the length of first triangle is to upon the length of bigger triangle. That means AB upon AP. This implies AB upon AP will be equal to AC upon AQ, the length of smaller triangle upon the length of bigger triangle for base unit. Similarly, for perpendicular unit, what it will be? The length of BC upon PQ. It will be equal to BC upon PQ. So, by showing this similarity, we can say that these three will be equal. What we are going to prove? We are wanting to prove BC by AB equal to PQ by AP. BC by AB, that means BC by AB is equal to PQ by AP. That means we are requiring these two ratios. We are requiring these two ratios. So we will equate these two ratios. Thus, AB by AP, on comparing AB by AP is equal to BC by PQ. What we will get? We will try to cross multiply the things. It will be like AB by BC equal to AP by PQ. So these two will be equal by cross multiplying. Now what we are given? We are given sine of angle theta is BC by AB and PQ by AP. PQ by AP. But what we are getting? AP by PQ, the opposite of that thing. So what we can do, when we divide both the terms with 1, when we reciprocate both the things, what it will be? BC by AB is equal to PQ by AP. So we got what we wanted. This BC by AB is now equal to PQ by AP. So from here, what is BC by AB? What is BC by AB? So our BC by AB is sine of angle theta of triangle ABC, and similarly PQ by AP is what? Sine of angle theta of triangle APQ. So we can say this as sine of angle theta of triangle ABC is equal to sine of angle theta of triangle APQ. So the trigonometrical ratios will always be equal for same angles. For same angles, the trigonometrical ratios will always be equal. Similar the case will be for cosine of theta. Similar the case will be for tangent of theta and all other trigonometrical ratios. Okay. So it is very important because many questions will come uh, by using the similarity concept to solve. Okay. Now moving to our next part. What is our next part? Our next part is opposite relations. We have studied it, but we will do some more formulation from this. Okay, we know that opposite of sine theta is cosec theta. That means 1 by sine of angle theta is equal to cosecant of angle theta. What does it mean? When we cross multiply the things, we will get cosecant of angle theta. When multiplied with sine of angle theta, it will give 1. It will provide 1. Similarly, we know that opposite of cos theta is equal to sec theta. Opposite of cos theta is equal to sec theta. That means secant of angle theta. So, what we will get? Secant of angle theta multiplied with cosine of angle theta is equal to 1. We have to remember these identities. We have to remember these identities because in questions we will require these identities. Okay. To solve the questions we will require these identities. Similarly, 1 upon tangent of angle theta will be equal to cotangent of angle theta. Okay. So, what it will be? Cotangent of angle theta into tangent of angle theta will be equal to 1. Okay. This is our next part. Our tangent of angle theta will be equal to sine theta upon cos theta. I know you will not understand it easily. So, let me prove it so that you can understand it better. Okay. Let us suppose that what is our tan theta? We know that our tangent of angle theta is actually perpendicular upon base. It is actually perpendicular upon base. So, how we know? Pandit Badri Prasad Hari Hari Bol. Pandit Badri Prasad Hari Hari Bol. So, this was our tangent of angle theta. It is P upon P. Okay. So, what I am trying to say, this tan theta is equal to P by 2, P by B. This is our LHS. This is our LHS. When we go to our RHS, what it will be? We know that our sin theta upon cos theta. What is our sin theta? So, for Pandit Badri Prasad Hari Hari Bol, Pandit Badri Prasad Hari Hari Bol, in this mnemonic, we know that sin theta is P upon H. So, it will be P upon H perpendicular upon hypotenuse. Okay. And cosine of angle theta will be B upon H. What it will be? It will be B upon H base upon hypotenuse of that triangle. So, this hypotenuse will be cancelled and we will get the value as P upon B. So, our LHS is now equal to RHS. This implies tan theta is equal to sin theta upon cos theta. Similarly, our cot theta is equal to cos theta upon sin theta. Let us take LHS. What it will be? Cotangent of theta is equal to what it will be? Cotangent will be B upon P, opposite of tan. That means it is B upon P. And for RHS, cosine of angle theta upon sine of angle theta, it will be equal to, this cos will be equal to, cosine will be equal to P upon H, and similarly sine will be equal to, sine of angle theta will be equal to P upon H. And on the similar basis, we can say that it will be equal to B upon P. Okay. So, what we got? Cot theta equal to cos theta upon sin theta. Okay. We will recall all the terms later. Okay. Now, we are moving towards square relations. The square relations between these trigonometrical ratios. So, first is our sin square theta plus cos square theta is equal to 1. You will say how can you prove it? So, let me prove it for you. So, this is my proof. Sin square theta is what? It is actually p upon h, that is perpendicular upon hypotenuse whole square. Similarly, cosine of square of theta is actually what? It is b by h, that means base upon hypotenuse whole square. This is our LHS, left hand side part. Okay. So this is our LHS. So it can be written as p square upon h square, because we know that a by b to the power m, a by b to the power m is equal to a to the power m divided by b to the power m, plus it will be b square upon h square. Okay, it will be b square upon h square. Now, on taking LCM, we will get h square, we will get h square. So it will be here in the numerator, it will be p square plus b square. Now we know that we have to first of all know the Pythagoras theorem. What Pythagoras theorem states? Pythagoras theorem for right angle triangles says hypotenuse square is always equal to base square plus perpendicular square. So this h will be equal to root under b square plus p square. So this p square plus b square is actually h square, this hypotenuse square. So hypotenuse square upon hypotenuse square will give the value as 1. So we have proved our first square relation identity, that is sin square theta plus cos square theta is equal to 1. We have to remember it always, because many questions will be done by using this identity. Now, our second identity. Our second identity is sec square theta, that means secant of theta whole square minus tangent of theta whole square is always equal to 1. It is always equal to 1. So let us check it. Proof. Sec square theta is what? Sec square theta, that means secant of theta whole square is actually h upon b whole square. We know that cos of theta is b upon h, cosine of theta is b upon h, and secant of theta is opposite of cosine of theta, so it will be h upon b. So sec square theta, that is secant of theta whole square, is actually h by b to the power 2. Similarly, tan theta whole square is what? That means tan square theta is, we know that tan theta is p upon b. So it will be p upon b whole square. Pandit Badri Prasad Hari Hari Bol. This tan theta is p by b. This sec theta is h by b. Okay. So what we get for LHS, sec square theta is h square upon b square minus tan square theta is p square upon b square. So it is our LHS. It is our LHS. Now, here b square will be taken as LCM. So in the numerator it will be h square minus p square. We know that by Pythagoras theorem, h square is equal to b square plus p square. So this b square will be equal to h square minus p square. So this h square minus p square will be equal to b square. So it will be b square upon b square, and b square upon b square will give the value as 1, which is equal to RHS. Hence, we can say that sec square theta minus tan square theta is equal to 1. Similarly, this is our third identity and the last identity which we are going to know. Our third identity is cosec square theta minus cot square theta. That means cosecant of theta to the power 2 minus cot tangent of theta to the power 2 is always equal to 1. It is always equal to 1. So, we will prove this also. What will be our cosec theta? That is cosecant of theta. Cosecant of theta will be what? Opposite of sine of angle theta. Sine of angle theta is actually P upon H. So cosecant of angle theta is equal to H upon P. So it will be H by P to the power 2 minus cot of theta is the cotangent of theta is the opposite of tangent of theta. So it will be equal to B upon P to the power 2. So this is our LHS. We are moving towards our LHS. It will be H square by P square minus B square by P square. So it is equal to this P square. This P square will be the LCM. So we will be writing P square, and in the numerator it will be H square minus B square. So we know that H square is equal to B square plus P square. So this H square minus B square will be equal to P square. So it will be equal to P square upon P square, and it will be equal to 1. So from this we can say that it is our RHS. Our LHS is equal to RHS. Hence we can say that cosec square theta, that means that cosecant of theta to the power 2 minus cotangent of theta to the power 2 is equal to 1. Okay. So what we have learned till now? We have learned that sine theta, that means sine of angle theta, is equal to P upon H. Cosine of angle theta is equal to B upon H. Tangent of angle theta is equal to P upon B. We have learned these three. Similarly, cosecant of theta, angle theta is equal to H upon P. Secant of angle theta is equal to, that means sec theta is equal to H upon B, and cotangent of angle theta equals to B upon B. We have learned these first. After that, we learned that cosecant of theta when multiplied with sine of angle theta is equal to 1. Similarly, secant of angle theta when multiplied with cos of angle theta, cosine of angle theta, it gave 1. Similarly, cotangent of angle theta when multiplied with tangent of angle theta, it gave 1. What else we learned? We learned tangent of angle theta is equal to sine of angle theta upon cosine of angle theta. Okay, we also learned this, and we also learned that this cotangent of angle theta is actually opposite of this, opposite of tangent of angle theta. So it is cotangent into tangent of angle theta is equal to 1 upon tangent of angle theta is equal to cos theta upon sine of angle theta. So this cotangent of angle theta is actually opposite of tan theta, that is cos theta, cosine of angle theta upon sine of angle theta. We have learned this. Also, we have learned three square relations. What were they? They were sine square theta plus cosine of theta to the power 2 is equal to 1. Sine of angle theta to the power 2 plus cosine of angle theta to the power 2 is always equal to 1. Similarly, secant of theta to the power 2 plus minus tangent of theta to the power 2 is always equal to 1. Similarly, cosecant of angle theta to the power 2 minus cotangent of theta to the power 2 is always equal to 1. So, we have learned these things in this chapter. By using these things, we will solve our question of this chapter. Okay.